Okay, today we are going to learn two specific discrete random variable. What are they? One of them is called discrete uniform distribution, and one of them is called binomial distribution. After today's class, you will be able to recognize discrete uniform distribution and solve problems involving discrete uniform distributions. Recognize conditions that give rise to a binomial probability distribution. Make connections among table, bar chart, and algebraic representation of a binomial distribution, and solve problems involving binomial probability distribution. Okay, let's see the first one. Because the first one is very simple, it is actually discrete uniform distribution. It's very simple, the simplest distribution that we will discuss. So I encourage you to read the textbook by yourself. The textbook is located on your Google Drive. Just check textbook chapter 4. All right. If you have time, you can check the textbook by yourself. Okay, I'll make a brief summary of what the uniform distribution is and what features it has. Okay. Okay, simply speaking, one probability distribution have when a random variable has this probability distribution, it is a discrete uniform distribution. Okay, more explicitly, when a random variable has a probability distribution like this, okay, the values it can be are x1, x2, and xn. And the probabilities of being such values are the same because it has n values. If all the probabilities are the same, the probabilities should be 1 over n, right? 1 over n, 1 over n, 1 over n, 1 over n. Because the sum of these probabilities is always equal to 1, right? Okay. If a discrete random variable has such probability distribution, we call it discrete uniform distribution. In Chinese, we call it 离散均匀分布. Why is it uniform? Because all the probabilities of being each value are the same. 为什么叫做离散均匀分布？因为 x 能取到这些值的概率都是相等的，能明白吗？这个叫做离散均匀分布。Okay, so what's so special about discrete uniform distribution? When we calculate the mean, as you can see, when we calculate the mean, it's x1 by 1 over n plus x2 by 1 over n plus xn by 1 over n, right? Because 1 over n is a common factor, so we can put it in front according to the distributive law. So it's 1 over n multiplied by the sum of x1, x2, and xn, right? So basically it's 1 over n multiplied by a sum, x1 to xn. So for a discrete uniform distribution, you can use this formula to calculate its mean. If you do not like this formula, you can use the original formula. That is, Ex is the sum of each value multiplied by the corresponding probability. There's no problem because the original formula is applicable to any circumstances, right? As to the variance, there is no simple way to calculate the variance. Just use a formula we have learned so far. The variance of x, to calculate this, you will need to calculate the expectation of x squared and use this value minus the expectation of x squared. There's no simpler way for discrete uniform distribution to calculate the variance, right? Okay, let's see some examples then. Okay, the first question, fair game. Is it a fair game or not? The game involves rolling a die. A player who rolls an even number receives points equal to 2 times the face value of the die. If the player rolls an odd number, the player loses 3 times the face value of the die. Is this a fair game? Hint, if the expectation of point 1 is 0, then it is a fair game. Okay, what does it mean? It means a game involves rolling a die, right? If you rolled 1, because 1 is an odd number, so you lose this 3 times the face value of the die. That means when you roll that, when you rolled 1, you get minus 3 points, right? Okay. Similarly, when you roll a 4, for example, because 4 is an even number. When you roll an even number, you receive points equal to 2 times the face value of the die. That means when you roll a 4, you receive 8 points, right? Okay. So to determine whether this is a fair game, it gives you a hint. If the expectation of points 1 is a 0, then it is a fair game. Otherwise, it is not. So the key is to calculate the expectation that points 1, right? Okay. So what numbers can you roll? Okay, we can make a list here. What numbers you can roll? Using standard die, you can roll 1, 2, 3, 4, 5, 6, right? And when you roll different numbers, you can receive different points, right? What points can you receive? The corresponding points you receive are -3, 4, -9, 8, -15, 12, right? Because according to this rule, these are the points you receive corresponding to different numbers you roll. And the probability of receiving these points is determined by the probability you roll different numbers, right? Because this is a fair die, means the probability of rolling each number is 1/6, right? 1/6, because it has 6 faces. As you can see, the points you receive, the probability of these points you receive are the same. They are all 1/6. So we use a letter X denote the point you receive. Then X is a uniform distribution, right? Because each value has the same probability. So we need to calculate the expectation of X, which is 1/n multiplied by the sum of xi, right? Okay, 1/n, n is your number of sample points. So we have 1, 2, 3, 5, 6 sample points here, multiplied by all the points you receive. That is -3 plus 4 minus 9 plus 8 minus 15 plus 12, which is, okay, 1 minus 3, right? Okay, so the final result is minus 0.5. Because expectation of X is not 0, so you can decide that it's not a fair game. Right? That means actually the expectation of x is a minus value. That means on average, you will lose points than receiving points, right? Okay, any questions? All right, let's see the next one. A random number generator provides a number between 1 and 10. What is the expected outcome? Okay, here it gives you a random variable. And it asks you to calculate the expected outcome, which means the expectation of this random variable, right? Okay, I'll leave you 2 minutes to solve this question. All right, have you finished? Okay, this random variable is actually discrete uniform, right? Because the values, it can be 1, 2, 3, and 10. Because it's a random number generator, that means the probabilities of being this value are the same, which are 1 over 10, right? So the expectation of x is 1 over 10 multiplied by the sum of all possible values, okay, which is 5.5, right? So the correct answer is D. Okay, any questions? No? All right, let's see the next one. Given the probability distributions, determine the expected values. Okay, there are two sub-questions. Okay, you're given 5 minutes to solve them, and then we'll discuss this together. All right, have we finished? Let's see this first one. Expected values of x, according to the formula we have learned, is 1 over n and multiplied by sum of all possible values of x, right? Because we already know that it's a discrete uniform distribution, as all the probabilities are the same. So 1, 2, 3, 4, 5, we have 5 values. Cool. Okay, this is 1 over 5 by which is 15, right? Okay, number 2, expected values. Again, this is a discrete uniform distribution because all the probabilities are the same, right? Okay, and 1 over n xi sum, okay, which is multiplied by okay. Which is 3.5, right? Okay, any questions? No? Okay, let's see the next one. A target contains circles with radius of 8 centimeters, 12 centimeters, and 20 centimeters. If a dart randomly lands on one of the 3 regions, show mathematically that this is not a uniform distribution. Okay. To show whether this is a uniform distribution, the key is to find if the probabilities are the same, right? So you need to calculate the probability of landing on A, the probability of landing on B, and the probability of landing on C, right? If there exists that at least what, if we can find that any of the two are not equal, then it is not a uniform distribution, right? Okay, so how to calculate the probability of landing on A, B, or C, respectively? We need to calculate the area of the circle, right? The very large circle with a radius of 20. So here is 20. So the area of the very large circle is pi 20 squared, which is 400 pi, right? Okay, and then we'll calculate the area of circle C, which is with a radius of 8. So here we have 8 squared multiplied by pi, which is 60 pi, right? Okay, and then we need to calculate the area of, for example, we calculate the area of B, which is the circle, the large circle minus the small circle, right? Okay, this circle, the radius of this circle is 12. So here is actually pi 12 squared minus pi 8 squared, which is 144 pi minus 64 pi, which is 80 pi, right? Okay, so here we can find PC. PC is actually the total area. And here we have 64 pi over 400 pi, right? And PB is actually the area of B, which is 80 pi over 400 pi. You can easily find that PC is not equal to PB. So this is not a uniform distribution. Okay, because PC is not equal to PB, we do not need to calculate PA, right? Because we have already proved that PC is not PB. If it is a uniform distribution, all these three probabilities are equal. And now here we have already proved that PC is not PB. So there's no need to calculate PA now. Any questions? Any questions? Okay, no. All right, let's see the next distribution. Okay, this is very important. This is a key point in this unit, which is binomial distribution. Okay, first of all, we need to know what is binomial experiment, and then based on that, we need to know what is binomial distribution. For a binomial distribution, what is the probability distribution, and how to calculate its mean and standard deviation? Are there any simpler ways of calculating this? And there are also some applications of binomial distribution. Okay, following this outline, first, let's see what is binomial experiment. Okay, I'll read this definition for you. Conditions of a binomial experiment. There are 4 conditions. A binomial experiment must satisfy the following 4 conditions. 1. There are unidentical trials. 2. Each trial has only 2 possible outcomes or events. In other words, the outcomes of a trial are divided into 2 mutually exclusive events. 3. The probabilities of the 2 outcomes or events remain constant. 4. The trials are independent. Remember, there are 4 conditions of a binomial experiment. Okay, then let's see some examples. Consider the experiment consisting 10 tosses of a coin. Determine whether or not it is a binomial experiment. Okay, let's see whether this experiment has the 4 conditions we just mentioned previously. Okay. First condition, there are a total of 10 trials, right? And they are all identical. First condition, 10 trials, all identical. So fulfills first condition, right? Number 2, each trial has only 2 possible outcomes, right? Each trial has only 2 possible outcomes. So also fulfills the second condition. Number 3, the probability of obtaining a head and that of a trial is 1/2 for any loss, right? Okay. The probability of the 2 outcomes are constant. Why is that constant? Because P head is always 1/2. P tail is always 1/2, right? The probability of being a head never changes. Similarly, the probability of being a tail never changes. So these 2 outcomes, the probabilities of these 2 outcomes are constant. So it fulfills the third condition. How about the first one? The trials are independent, right? Because whether you toss a head or tail does not affect the next toss. Okay, that means the trials or tosses are independent. They do not affect each other. So the statement fulfills all these four conditions. So this is a binomial experiment. Okay. Any questions? Okay, let's see the next example. 5% of all DVD players manufactured by a large electronics company are defective. 3 DVD players are randomly selected from the production line of this company. The selected DVD players are inspected to determine whether each of them is defective or good. Is this experiment a binomial experiment? Okay, again, let's check for conditions. 1. How many trials are there? Are these trials identical? Okay, actually there are 3 trials, right? Why? Because the inspector selects 3 DVD players, right? So each selection is a trial. 3 trials, all of them are identical. Okay, so it fulfills first condition. Second one, each trial has 2 outcomes, right? What outcomes? Whether they are defective or good, right? So there are only 2 outcomes for each trial. So the second condition is fulfilled. Okay, third one, because it's a very large electronics company. So the probability of being defective is always 5%, right? So for each trial, the probability of the 2 outcomes, or probabilities of the 2 outcomes remain constant, right? Which is actually the probability of being defective is always 5%. And the probability of not being defective is always 95%. So the third condition is fulfilled. Okay, the fourth one, each trial is independent, right? Because whether you chose a defective one or perfect one does not affect the result of the next one. So they are all independent. Okay, all 4 conditions have been fulfilled. So this is a binomial experiment. Okay, any questions? Okay, again, let's see another example. A box contains 20 cell phones and 2 of them are defective. Okay, we have a box of 20 cell phones. Okay, of which 2 are defective. That means 18 are not defective, right? 3 cell phones are randomly selected. Okay, we choose 3 out of the 20 from this box and inspected to determine whether each of them is good or defective. Is this experiment a binomial experiment? Okay, let's check the conditions one by one. Okay, 1. Are these trials identical? Actually, they are not, right? Because you only have 20 phones there. When you choose the first phone, there are 20 left in this box, right? This is your first trial. Okay, when you choose the second phone, this is your second trial. There are only 19 left there, right? The conditions are not the same, so they are not identical. Okay, the trials are not identical. So you don't have to check other conditions because the first condition is not fulfilled. So this is not a binomial experiment. Okay, any questions? Okay. All right, so what is a binomial random variable? Actually, the binomial random variable comes from the binomial experiment. Okay, pay attention to this definition. If x is a random variable and x yields to a binomial distribution, it's denoted as x yields to a binomial distribution NP. So what is a binomial random variable here? For a binomial experiment, the probability of exactly x successes in n trials is given by the binomial formula. The probability of x is Cnx p to x times q to n minus x times, where n is total number of trials, p is probability of successes, q is 1 minus p, that is probability of failure. X is number of successes in n trials. N minus x is the number of failures in n trials. Okay, what does this mean? It means when you conduct n identical trials, for each trial there are 2 outcomes, right? Whether it's something successes, okay, something successful, or the opposite, right? Or the opposite happened. It can only have these 2 outcomes, right? For each trial, right? And when we completing these n identical trials, I denote the number of successful trials as x, right? I can denote the number of successful trials as x. So what the values x can be? X could be 0, right? After the n identical trials, you can find that there's no successful trials. X can also be 1, right? Because there can only be 1 successful trials. X can also be 2, etc. And the maximum number X can be is n, right? That means all n trials are successful. So here we have X is actually a random variable, right? Because it comes from a binomial experiment. So X here is binomial random variable. We denote it as x yields to a binomial random variable. First parameter is n. That means you conducted n trials. And the second parameter is p, which means for each trial, the probability of being successful is p. Understand? And if x yields to a binomial random variable, actually the probability of x being any value of k for k is 0, 1, 2 until n is given by this formula, which is Cn k p k and 1 minus p k. Understand? Any questions? Okay. Furthermore, if x if x yields to a binomial distribution with first parameter n and second parameter p, the expectation of x mu is np and sigma is npq. Actually, we can prove this according to the original definition of expectation and standard deviation. You don't need to know how we prove that. This is final result. Just remember that if x yields to a binomial distribution, there are some simpler ways to calculate its mean and standard deviation. Of course, as well as variance. Okay? All right. I'll explain the whole thing in Chinese again. All right? To help you understand. Okay, in Chinese. 二项分布是怎么样一个分布呢？实际上是这样的啊。假如说我们每做一次随机实验，事件 A 可能发生，也可能没发生，这是可能的，对不对？注意啊，每做一次随机实验，事件 A 可能发生，也可能没发生。假设每次试验事件 A 发生的概率为 P， 可以吧？重复做 n 次这样的随机实验也是可以的吧？然后我们记事件发生的总次数 x 为随机变量，那这个 x 肯定是随机变量，对不对？因为什么？你做了 n 次随机实验嘛，最少这个次数发生的次数是0，对不对？最多的 x 也可能每次都发生了，那 x 就等于 n 了，对不对？好，如果我们记这样一个 x 是随机变量的话，那么这个 x 就服从二项分布，即为什么呢 ？x 服从二项分布 ，b 两个参数分别是 n p。好，例如啊，每次投硬币正面出现的概率是 0.5， 对不对？一共投10次，则正面出现的总次数 x 服从二项分布，对吧？或者是每次投硬币正面出现的概率为 0.5， 一共投1次，则正面出现的总次数 x 服从二项分布，可以记为什么 x 服从二项分布 1p， 对不对？上面那个是 x 服从二项分布 10p， 意思是做了10次随机实验，每次这个事件出现概率是 0.5， 可以吧？对，好，总结一下啊，也就是说，如果 x 服从二项分布，那么 x 等于任何一个值 k 的概率是由这个公式来给出来的 ，cnk pk qn 减 k， 其中 x 是事件发生的总次数，它是一个随机变量 ，n 是总的实验次数 ，p 是每一次实验当中事件发生的概率 ，q 等于什么呢 ？q 等于1减 p， 为每一次实验当中事件不发生的概率。OK。What I just talked about in Chinese is actually the same with what we have discussed in English. So if you do not speak Chinese, that's okay, because we have already explained everything in English. All right, let's then make a final summary here. Okay. If x yields to a binomial experiment, if x yields to a binomial distribution with two parameters, first parameter n, second parameter p, that means you conducted n identical trials. In each trial, the probability of being successful is p. Then we have the following conclusions. First of all, the probability of x being k is given by this formula, cnk pk 1 minus p to the k. And then the expectation of x is n multiplied by p. N is the total number of trials. P is the probability of being successful in each trial. The variance of x is NPQ, where Q is 1 minus P. That means the probability of being failure, right? Okay. Standard deviation, of course, is square root NPQ, where again Q is 1 minus P, is a probability of being failure. Okay, any questions? This is the definition of a binomial random variable. Okay, let's see some concrete examples to help you understand. Okay, first example, 5% of all DVD players manufactured by a large electronics company are defective. The quality control inspector randomly selects 3 DVD players from the production line. What is the probability that exactly one of these 3 DVD players is defective? Okay. As we have already discussed in previous, this is actually a binomial experiment, right? Why? Because there are 3 identical trials. 3 identical trials. And in each trial, there are only 2 outcomes, right? Which are defective or not defective. Defective or not defective. That means perfect. Okay. And for each trial, the probability of being defective never changes, remain constant, right? The probability of defective is always 5% because it comes from the same production line. And it means the probability of not being defective is always 95, right? And they are independent trials. They do not affect each other. So this is a binomial experiment. And here, it asks you the probability of exactly one of these 3 DVD players is defective. Okay, so here we should use a letter to denote the random variable, right? Okay, usually we use letter uppercase X. Let X denote the number of defective DVD players in the chosen 3. Then according to our analysis, X apparently yields to a binomial distribution, right? The first parameter is N. N is 3 because we conducted 3 trials. And the second parameter is P. P is the probability of being successful. How is it denoted as successful? Here it asks you to find the probability of defective ones, right? So here the probability should be the probability of being defective. It is always 5%, right? Okay, so here it actually asks you to find the probability of X being 1, right? Because here it says exactly 1 of these. So we are going to calculate the probability of X being 1. And according to binomial formula, the probability of X being 1 is CNK. N is 3, K is 1. Okay, PK, that means 5%, 1, and 1 minus P, which is 95%. N minus K, which is 2, right? So the final result is 0.1354. Okay, so this is the whole process. Okay. in your homework or in your test or assignment, you don't have to write these. This should be from your brain. You should come up with ideas using your brain, not need to write them on your answer sheet, right? This is analysis. This is a reasoning process. Reasoning process that determines X is a binomial. That determines the binomial experiment. If it is not a binomial experiment, we cannot use this method, right? Okay. Any questions? Any questions? No? All right, let's see another example. At the express house delivery service, providing high quality service to customers is the top priority of the management. The company guarantees a refund of all charges if a package it is delivering does not arrive at its destination by the specified time. It is known from past data that despite all efforts, 2% of packages mailed through this company do not arrive at their destination within the specific time. Suppose a corporation mails 10 packages through express house delivery service on a certain day. A. Find the probability that exactly one of these 10 packages will not arrive at its destination within the specified time. B. Find the probability that at most one of these 10 packages will not arrive at its destination within the specified time. Okay. To solve such question, usually we need to know what is a random variable here, right? Usually we denote it as X, the meaning of the random variable. What is the RV here? And then we check if the random variable here yields to some specific distribution. If it is, we can use the specific formula for this specific distribution, right? Okay, so first of all, you need to check what is the random variable here. Okay, you have to find it from the original statement. Okay, actually here, you mailed 10 packages, which is equivalent to actually you conducted 10 trials, right? After you conducted trials and you check how many packages do not arrive within the specified time, right? So what is the random variable here? The number of the packages that did not arrive within the specific time is the random variable, right? So first of all, we should explicitly state that X denote the number of packages that do not arrive in time. Then here X is a random variable, right? Because you mailed 10 packages, X denotes the number of packages that do not arrive in time. X can be 0, right? That means all of them arrive in time. X can also be 1, 2, 3 until 10, right? If X is 10, that means all of the packages do not arrive in time, right? And according to this statement, actually, as X yields to a binomial distribution, right? because you conducted 10 trials. In each trial, there are only two possible outcomes. That is, arrive in time and not arrive in time. And the probability of being arrived in time is always 2%. Oh, sorry. The probability of not arrive in time is always 2%, right? So X here is actually a binomial experiment. Okay. According to this analysis, you should be able to solve this question now. And I'll leave you 5 minutes to solve it, okay? All right, have you finished? Okay, as I said, let X denote the number of packages that do not arrive in time. Then our X here yields to a binomial distribution, right? First parameter is N. N is the number of trials you conducted. That actually means you conducted 10 trials because there are 10 packages, right? We test 10 packages. That means we conducted 10 trials. And for each trial, the probability being successful, that means the probability of being not arrive in time is 2%. Okay, so in the first question, it asks you the probability of X being 1, right? Because it says here, exactly one of these will not arrive in time. Okay, X being 1. That means according to the binomial formula, the probability of X being 1 is Cnk. N is 10, K is 1. P is 2%. P to the K times K is 1. Okay, 1 minus P is 98% to N plus K times, which is 0.1667. Okay, as to question B, find the probability that at most one of these, at most means at most one, means X could be 1 or less than 1, right? That means X is 1 or less than 1. Okay. Okay, that means the probability of this event is actually two parts. The first part is X being 1, right? The second part is X being 0. Okay, we have already known that the probability of X being 1 is 0.1667. And the probability of X being 0, we need to calculate this again, is Cnk. P to K times, and 1 minus P to N minus K times, which is 0.9838. Okay, any questions? All right. Okay. All right, let's see the next example then. In the Pew Research Center nationwide telephone survey conducted in March through April 2011, 74% of college graduates said that college provided them intellectual growth. Assume that this result holds true for the current population of college graduates. Let X denote the number in a random sample of 3 college graduates who hold this opinion. Write the probability distribution of X and draw a bar graph for this probability distribution. Okay, here it already gives you the random variable, right? Because here it says, let X denote the number in a random sample of 3 college graduates. And it asks you to find the probability distribution of X and draw a bar graph. Okay. All right, I'll give you 5 minutes to finish it. All right, let's solve this problem together. Okay, we have already know that X denotes the number in a random sample of 3 college graduates. So according to the analysis, X actually yields to a binomial distribution, right? The first parameter is N, which is the total number of trials you conducted here. Because here we check 3 college graduates, that means we conducted 3 trials. Okay, 3 trials, so N is 3. Second parameter is the probability of being successful in each trial. So according to the statement, 74% of college graduates said they have this opinion, right? Okay, so here P is 74%. If we want to find the probability distribution of X, we need to find all the values that X can assume and the corresponding probabilities, right? So here N is 3, so X can be 0 and can also be 1 or 2 or 3, right? Because we conducted 3 trials here. Of the 3 trials, there can be 0 successful, 1 successful, 2 successful, or 3 successful trials. Okay, according to binomial formula, the probability of X being 0 is C 3 0. Zero 0.74 to 0 times, and the opposite, which is 0.26 to 3 times, right? Which is approximately 0.0176. Okay, the probability of X being 1 is C31, 0.74 to 1, and 0.26 to twice, which is 0.1501. Okay, next we have C32, 0.74 twice, and 0.26 once. And last one is C33, 0.74 3 times, and 0.26 0 times. Okay. This one, last one is okay. So now we have all the possible values, that is 0, 1, 2, 3, and the corresponding probabilities, which are 0.0176, 0.1501, 0.4271, 0.4052. So this is our probability distribution. And based on this probability distribution, we can draw a bar chart that illustrates the probability distribution of X. So this is our Px, this is X. When X is 0, so the probability is 0.0176. When X is 1, the probability is 0.1501. Okay, and when X is 2, the probability is 0.4271. And when 0 is 3, the probability is 0.4052. Right? Any questions? Any questions? Okay, let's see the last example. Okay, I'm not gonna read this for you. I'll give you 5 minutes and then we'll discuss the solutions together. So basically here it asks you to calculate the mean and standard deviation. Mean and standard deviation of a certain random variable, right? Okay, have you finished? All right, here in this question, X is the number of adults in this sample who hold the above mentioned opinion. You should note that we have chosen 50 adults here, right? That means you conducted 50 trials. In each trial, 52% of people hold this 50% 52% probability is to with this opinion, right? So X here yields to a binomial distribution. N is 50. That means you conducted 50 trials. P here is 0.52. That means for each trial, the probability of having this opinion is 0.52. And then it asks you to calculate the mean, okay? We have already know that if X yields to a binomial distribution, EX is NP, which is 50 by 0.52, which is 26, right? Okay, VARX, standard deviation of X, because it asks you to calculate the standard deviation, right? Standard deviation for X is positive square root of NPQ, which is square root 50 by 0.52 by 0.48, which is approximately 3.5327. Right? Okay, any questions? No? All right, I'll make a brief summary for today's lesson. Okay, so today we have learned two specific discrete random variable. Okay, the first one is discrete uniform, which means that we have a random variable x, and x can be some different values, xn to x1 to xn, right? And the probability of them being these values are all the same, which are 1 over n. So in this way, x is uniformly distributed across these values. Okay, there is a special formula to calculate the expectation of x if x yields to a discrete uniform distribution, which is 1 over n multiplied by the sum of all possible values of x, right? This is a simple distribution, actually. Okay, the second one is a key, which is binomial distribution. Okay, and what condition x yields to a binomial distribution? Okay, there are 4 conditions. First, we conduct unidentical trials. And in each trial has only 2 outcomes. Whether A happen or A does not happen, that means the opposite of A happens, right? And the probability of A happening remain constant. We denote it as P. That means the probability of A not happening also remains constant. We denote it as Q. Actually, Q is 1 minus P, right? Okay. The first condition is that all the trials are independent. So if a random experiment fulfills these 4 conditions, this is a binomial experiment. And we denote X as the number of trials in which A happened. then x is a random variable, right? X can be any value between 0 to n, right? Then x yields to a binomial distribution. The first parameter is n. N is the number of total trials. The second parameter is p, which stands for the probability of A happening. And the probability of x being any value of k is given by this formula, which is Cnk pk 1 minus p n minus k, right? And the expected value of x is given by this formula. Similarly, the variance of x is npq, and standard deviation of x is square root npq. Okay, these are all the knowledge we have learned so far. Okay.